we introduce Spatial Reasoner, our latest efforts towards explicit and generalizable 3D spatial reasoning. Recent advancements of spatial understanding have driven remarkable progress in embodied AI and robotics. The capability to comprehend scene layouts, object relationships, is crucial for egocentric or allocentric reasoning, planning, and occlusion reasoning in downstream tasks. Notably, 3DSR Bench presented a comprehensive evaluation of image spatial reasoning, spanning 12 question types from 4 main categories. Prior research focused on data-driven approaches. In particular, synthetic data with 3D pseudo-labels are generated and then used as post-training data for fine-tuning vision-language models. These methods presented a scalable approach towards enhanced spatial understanding. However, in order to achieve genuine spatial intelligence, we want models built with minimal human designs and, at the same time, better generalization to novel spatial reasoning. One motivation example is by Gemini 2.0. In this example, the models successfully produce a step-by-step reasoning of the question, breaking down into smaller and tractable steps. However, it still failed to produce a correct answer, as the model cannot carry out these 3D spatial reasoning reliably. In this work, we propose to first build an interface for rigorous spatial reasoning, where explicit 3D representations, such as locations, orientations, and distances, are shared between different stages of the reasoning. Then, based on the 3D knowledge learned in the first stage, we adopt RL-based post-training, where the model learns to integrate the 3D knowledge into its reasoning trajectory. Specifically, we adopt a 3D-aware reward design, where the model is encouraged to predict explicit 3D representations, such as 3D coordinates and vectors, rather than vague language descriptions. Results show that our model can integrate the explicit 3D representations into its reasoning trajectories and achieve more reliable and generalizable spatial reasoning. Results show that chain-of-thought reasoning integrated with explicit 3D representations, we can further visualize the reasoning trajectories in a 3D visualizer, highlighting how the 3D parsing and reasoning is conducted. This also helps to pinpoint the error when wrong answers are predicted. Results show that our spatial reasoner achieves state-of-the-art performance on 3DSR Bench and demonstrated better data efficiency with the explicit 3D representations. Moreover, our model generalized better to novel question types compared to the baseline with only 3 DSFT. Please refer to the project page to learn more about our spatial reasoner.